Welcome to Algeomulus Prep Academy. Today's lesson is related rates of change moving on a curve. A point is moving along a graph of y 2x cubed plus 4x squared. At what point on the graph does the rate of change in the y-coordinate move twice as fast as the rate of change in the x-coordinate? First, we need to visualize the problem by sketching a graph. f of x is a cubic function, and we need to plot the points where the rate of the y-coordinate is moving 2 times faster than the x-coordinate. As you can see, this may occur on more than one point on the graph. Since we know that the y-coordinate is moving 2 times faster than the x-coordinate, we can write dy dt is equal to 2 dx dt. Next, since the equation of the function was already given to us, y is equal to 2x cubed plus 4x squared, we can differentiate both sides of the equation. We will get dy dt is equal to 6x squared dx dt plus 8x dx dt. Now in the corner, we'll write another given. dy dt is equal to 2 dx dt. We know that dy dt is equal to 2 dx dt. We can substitute it into the equation to eliminate an unknown variable. Since every term on both sides of the equation has dx dt, we can factor it out to eliminate another variable. This will leave us with a basic quadratic function, which we can then use to solve for x. Now that we've gotten the formula, which is 6x squared plus 8x minus 2 is equal to 0, we can now use the quadratic formula, which is written in the corner for your reference in green. Now we plug in all the stuff into the quadratic formula, and we get x is equal to negative 8 plus minus the square root of 8 squared minus 4 times 6 times negative 2 divided by 2 times 6, which is equal to negative 8 plus minus the square root of 112 divided by 12. On the previous slide, we found that x is equal to negative 8 plus minus the square root of 112 divided by 12. This splits into two different x's as shown on the board. For the sake of this problem, we will be simplifying it down. The first x equals negative 1.5486, and the second x equals 0.2153. To find the y-coordinate, we can substitute the x values that we just found in the previous step back into the original equation, which we have two of. In the first equation, we get 2.1651, and in the second equation, the y is equal to 0.2053. To answer the equation at negative 1.5486, 2.1651, and 0.2153, 0.2053, the point is moving 2 times faster in the y direction than the x direction. There are 2 points on a graph, point A and point B. Point B lies on the x-axis and point A lies on the y-axis. If point A is always 25 units away from point B and point B is moving away from the origin at a rate of 2 units per second, what is the rate of change for the angle of point B when point A is 5 units away from the origin? Let's start by visualizing the problem on the graph and identifying variables given to us. Point B lies directly on the x-axis, while point A lies directly on the y-axis. They will make a right triangle. This forms a hypotenuse with a length of 25 units. To make this problem easier to understand, we will make another graph showing the change. We can see after a few seconds, point B moves away from the origin to the right at a rate of 2 units per second. For the sake of making this problem easier to understand, let A equal y and B equal x. dx dt equals positive 2 units per second. We need to find d theta over dt when A is equal to 5 units. By looking at the picture, we should assume that d theta over dt will be negative since the angle is getting smaller and smaller. Let's restate our givens. We know that the hypotenuse or line AB has a length of 25 units. But line AB is a constant, so therefore we know that dAB over dt is going to equal 0 units per second. We can use basic trig identities to help us solve the problem. We can use cosine since hypotenuse was already given to us, which is the distance between point A and B at 25 units. Then we can take the derivative of the equation, which we will get 3 theta over dt parentheses negative sine theta, which is equal to dx dt over 25. And since that we already know dx dt, we can substitute it in. Before we actually get to the real equation, we need to first find theta in order to solve for d theta over dt. We can use trig identity to solve for theta. The problem already told us that y is 5 units away from the origin, and the hypotenuse is 25 units. We can use the inverse sign to find theta of x. We get that theta is equal to the inverse sign parentheses 5 over 25, but do not simplify this for now because we'll plug it into the original equation later. Now that we have every variable, we can now plug them back into the derivative function to find the rate of change for the angle of x. d theta over dt is equal to negative 0.4 radians per second. Since the unit is in radians per second, we need to convert the answer to degrees per second. We can use the formula degrees equal to rad 180 degrees divided by pi rad. So we need to multiply the negative 0.4 radians per second by 180 divided by pi. The radians cancel out and we get negative 22.91831181 degrees per second. A point is moving along a semicircle with an equation of x squared plus y squared equals 25, where y is greater than or equal to 0. If the point passes through the coordinate 4, 3, and the x coordinate is decreasing with a rate of 2 units per second, what is the rate of change of the y coordinate? Let's start by sketching the graph of f of x, which is a semicircle. The problem tells us that the point is moving 2 units per second to the left in the x direction. We need to find the rate of change for the point in the y direction at the coordinate 4, 3. As you see from the graph, if the point is moving to the left, it is also moving up in the y direction. This means that if dx dt is less than 0, dy dt must be greater than 0. Now we can differentiate the equation that was given to us. X squared plus y squared is equal to 25. And we will get 2x dx dt plus 2y dy dt is equal to 0. The problem already gave us x and y, which is 4, 3, and dx dt, which is negative 2 units per second, so we can substitute them into the derivative equation to solve for dy dt. Add 16 to both sides and divide by 6 and we'll get dy dt, which is equal to 8/3 units per second. Thank you for watching. Make sure to like and subscribe.